GitLab is the faster path from idea to software. It's more than a code repository. It's one workflow that brings development, security, and operations teams together. No walls, no endless feedback loops. Use GitLab end-to-end or integrate it with the tools you love. And it lets you eliminate the rest to help reduce costs and boost productivity at the same time without trade-offs. With GitLab, teams can build software faster, automate software delivery, shorten cycle times, and increase developer productivity. And security is built in, not bolted on. Scan for vulnerabilities with every code push, automatically. It's the entire development process, all in the same place where everyone works. Because we're on this path together. The path from idea to collaboration to higher performing teams. With one comprehensive, innovation-driving, fast and secure DevSecOps platform. Software faster. GitLab.
Hi, everybody. Welcome to the webinar session today. We're going to give people just another minute or so to jump in, and then we'll get started. All right, let's kick it off. Thanks everyone for joining us today on our Git Basics webinar. We're excited to have you. My name is Taylor Lund. I'm a member of the customer success team here at GitLab, and I'm joined by my colleague, Chris Gatarte, who is a customer success engineer. We're excited to be with you today. Just a couple of housekeeping items before I pass it over to Chris. First off, this webinar is being recorded, so you can look for that recording as well as the deck to come through to your inbox here in the next day or two. If you have any questions that come up throughout the presentation, feel free to put those in the Q&A portion of Zoom, and we will be happy to answer some of those throughout, and Chris will have some time to answer a few at the end as well. And without further ado, I will pass it over to Chris.
Perfect. Thanks a lot, Taylor, for that intro. So again, my name is Chris Gatarte. I'm a customer success engineer here at GitLab. And in today's webinar, I'll be focusing on foundational or beginner concepts and usage for Git. So for example, you might be a developer coming from another source control management tool other than Git. So this webinar will really help you understand how Git works and how to utilize Git with GitLab. Just to set some expectations, detailed migration assistance from another source control management tool is out of scope for today's conversation. I'd recommend that you contact our sales team to inquire about our full service migration consulting package in case you need some handholding or assistance directly from our professional services team. I'll provide you a link at the end of this conversation for a description and contact form for that package. But if you prefer to migrate repositories yourself, I'll also have some resources available to allow you to self-service your migration. So without further ado, I'll go ahead and jump in to the next slide here to set up our agenda. So for today's topics, we'll be focusing on giving you some context on GitLab as a DevSecOps platform. We'll also go through the project overview page on GitLab itself. I'll focus on some Git terminology to help you kind of understand some key terms that I'll be referencing throughout the webinar, as well as you become more familiar with using Git and GitLab. Next, I'll talk about a little bit about Git branching strategies, some of the different approaches to creating branches within Git. Finally, next up, we'll also have a section where I'll be able to show you more interactively how Git works, so Git in action, how to clone a repository from a GitLab project repository, work with it locally, create some changes, push those changes commit those changes to a feature branch, push that feature branch to the remote repository, and then actually working within GitLab in a merge request to collaborate, do some code review, and then finally merging those changes into the main or default branch. Lastly, we'll share some good resources around migration to Git, as well as some additional introductory to Git resources to help you learn Git at your own pace. As Taylor mentioned, if you have any questions, please use the Q&A feature of Zoom to submit your questions to the team as I present today's webinar. Alongside me are some members of the GitLab customer success team who will be able to help guide you if there's anything that comes to mind, anything that you become inspired to ask with based on what I'm presenting. You don't have to wait till the very end to ask any questions. We'll get to them as soon as we can. So in terms of context here, before we dive into Git and using GitLab for source control management, let's take a step back. GitLab as a solution is a platform approach that brings together the entire software development lifecycle into a single application. A platform approach enables a value stream driven mindset, a mindset that shortens the time from idea to customer value and establishes a powerful flywheel for data collection and aggregation. The benefit of a value stream platform approach is the visibility across personas and projects so you can measure improvement and cycle times. And a platform approach unifies the entire experience so that organizations and companies like yourself can be faster than your competition, moving from an idea to the customer's value. With GitLab, we have the most comprehensive DevSecOps platform. GitLab is a solution to organizations that are looking to empower development teams, security teams, and operations teams to build better software faster. We give those teams better insights, greater efficiency, improved collaboration, and faster time to value. By uniquely creating this offering as a single application, we're best able to provide our customers with end-to-end visibility across the software delivery lifecycle. In a single application, GitLab provides all the functionality of a complete DevSecOps platform. We allow organizations to deliver software faster while strengthening security and compliance, thereby maximizing the return on software development. To make it a little bit more concrete and tangible, let's take a look at a typical workflow. From planning and creating software, to integrating and verifying software, to deploying and operating software, and to monitoring and improving software. Each of these steps brings in different stakeholders and teams in your company. Everyone plays a role, even when SecOps shifts left. This workflow also uniquely helps developers as security shifts left. With the solution, we help customers proactively identify vulnerabilities by integrating and automating vulnerability management within the development lifecycle. Issues can be identified, logged, triaged, tracked, and remediated all in the same application in GitLab. Developers can address vulnerabilities in real time, avoiding release delays. And what's most powerful is that our solution uniquely allows data to be collected from requirement to production. You can leverage this data to provide incremental checks along the way to ensure only the best code is merged and delivered to your customers. So just imagine the power of end-to-end visibility and insights that come from a platform like GitLab. One of our customers was able to use our value stream dashboards to identify their best performing Java engineers and deploy them to the most critical projects. Another customer was able to measure the cost of creating a new capability, demonstrating to the company exactly what their team is capable of. As a manager or executive, you'll get access to actionable insights from an application, team, project, line of business, and company level. You'll use this data to help teams become more efficient, drive better experiences, and ensure security and compliance needs are being met. So we have the most comprehensive DevSecOps platform, and we're just getting started. We're constantly innovating new capabilities in our platform, as you can see here. Typically, a customer will start using GitLab to solve their source code management and CI/CD challenges. So over time, a customer may expand their usage to get efficiency and value benefit across more of the development, security, and operations workflows. And with that expansion comes even more unified and actionable insights. So for today, we'll be focused on getting you started with source code management. and getting more familiar with Git. So GitLab offers all of the phases of a DevOps lifecycle, but we're going to start where you are. Many customers choose to adopt GitLab in a gradual process, starting with a use case where they feel the greatest pain. Typically, they start with either source control management or continuous integration. Sometimes they might start with agile project management, but most often it's SCM or CI. Then over time, our customers will adopt more capabilities in GitLab, including security and continuous delivery. And the common theme that we hear from customers is that as they adopt more breadth of GitLab capabilities, they uncover greater and greater value. So with that said, let's dive right into managing source code using Git on GitLab. First, we're going to go ahead and do an overview of the GitLab project. As a brief, before we dive into the GitLab project, as things are organized within the GitLab instance, we've got groups, and within groups, you may have subgroups, and within those subgroups, you'll have projects, or even at the top level group, you'll have a project as well. And in the project, that's where you store your source code in the project repository. If you need a deeper dive on GitLab organization and all the tools in the DevSecOps platform, definitely recommend you sign up for our Intro to GitLab webinar that's offered on a regular basis. So with an anatomy of a project within GitLab, you have a lot of different information that's present to you here. You have project information. You also have the repository. You'll also have issues, merge requests, CI and CD, security and compliance, deployments, packages and registries, infrastructure, monitor, analytics, and settings. So all this is available on the left-hand sidebar here. When we want to go into details of what's in the repository, we'll go to the Files tab. This Files tab shows the main branch, but a dropdown also has links to other branches. Commits helps you track changes made to all the different files. Branches show different variations of the main branch based on different feature branches that the team is creating. Tags are custom locations of the repository or even release points. Contributors shows a list of users who have contributed commits to the repository. Graph is a visual representation of your branches and the changes made and merged between them. Finally, compare allows you to compare changes between branches, tags, or specific commits using the hash of a commit itself. You can see here there's a diff, and you can see some of the changes between the two branches that I compared there. Next, I want to go into detail around the merge request. This is the equivalent of a pull request in other tools. To obtain feedback from other team members, you should create a merge request in GitLab. From there, you can assign or mention the person that you'd like to have review the code, and then you'd push corrections to that same feature branch as the collaboration happens in the merge request. So with this example here that I'm showing, I wanted to update a link in our documentation for our Slack integration. I created a new feature branch and then created a merge request to allow our technical writing team to review my changes. Later on, our product team got involved and wanted to revert the changes I proposed because we were going to do a larger scale change that would mitigate the need for any of my changes recommended in this merge request. All of that discussion and updates to our documentation happen right here in this merge request. So at GitLab, we do call a merge, and you use Markdown to format all of your comments, adding links, embedding images, quotes, and more. You can collaborate via the threaded messages or comments here to ensure you have context on the conversation that's happening. And finally, you can see what the proposed changes are by looking at the commits in the feature branch and what changes have been made using the diff interface on the changes tab. Next, we'll go through some key Git terminology. So here's some of the key Git terms that I'll be referencing and that you'll become more familiar with as you start to work more with Git and GitLab. Local repo or local repository is the local copy of the upstream repo on your local machine. The upstream repo is also known as remote. This is the hosted repository on a shared server or instance. In this case, and what you're using GitLab, for is that remote repository. Untracked files are new files that Git has not been told to track previously. Commits can be thought of as snapshots or milestones along the timeline of a Git project, and commits are created to capture the state of a project at that point in time. Working area are files that have been modified but not committed. A staging area is modified or added files that are marked to go into the next commit. A branch is an independent line of development, typically scoped to a feature or a bug fix. I also call them just feature branches if it's work targeted at integrating a new feature or for next iteration of the code base. The main branch is the canonical branch for the repository, also known as trunk. Fork is a personal copy of the entire repository that you're working with, and merge is when you bring two branches together. Some of the Git internal terminology, just to give you some context here. You've got object types of commit, tree, and blob. A commit contains the author, a commit message, which is a short description of what's contained in that commit, and a pointer to a tree of changes. A tree, on the other hand, a tree object is used to represent directories or folders of files and other subdirectories. A blob is essentially just data. Could be your source code, pictures, videos, etc. Those are all stored as objects on the file system in a file-based object database. It's also important to note that tags and branches are merely pointers to commits and are not full copies. And all of Git's content is stored as tree and blob objects, with trees corresponding to the directory entries and blobs corresponding more or less to the file contents. Continuing on, commits all reference their parent. Branches are named pointers to commits. Main is the canonical mainline branch, and head is a special pointer to the latest commit of the current branch, and it moves automatically for the current or active branch. Performing a clone or checkout starts at the current commit and works up to the parent chain, fetching tree and blob content. The Git checkout is an easy way to load any snapshots into your development machine, and Git clone is used to create a copy or clone of remote repositories. With Git clone, you pass the repository URL, and in this case, the GitLab project repository URL. So when working with a local repository, again, that's the local copy of the upstream repo on your local machine, consists of 3 trees: a working directory with the actual files of the current branch, the staging area, and the latest commit on the current branch, which is called head. All the work that you do locally is not seen on GitLab until you push to the GitLab remote repository. This allows you to work offline without network access and to push your changes for review whenever you're ready. As seen in the previous slides, GitLab is your primary collaboration tool for code review and merging changes from a feature branch to the main or default branch. Here, I want to take you through a basic Git workflow. Developing a project revolves around the basic edit, stage, and commit pattern. To start working, you can clone a repository from the remote server, in this case, GitLab. Alternatively, you can start a Git project in your local directory by using the git init command, which will start tracking changes from that directory. When you're ready to start working, make your changes. When you're ready to add these changes to the staging area, use the command git add. It helps to think of the staging area as a buffer between the working directory and the project history. Instead of committing all the changes that you made since the last commit, the stage lets you group related changes into highly focused snapshots before actually committing it to the project history. After you're happy with a stage snapshot, you commit it to the project history with git commit. Remember that all of this is being done on your own computer and machine. In order to make these changes to the remote server, we need to push them using the git push command. The cycle starts again when the developer needs to work on a new feature or bug fix. So run a git fetch command from their local machine to pull the most recent copy of the main branch into GitLab. Then they'll run the git checkout command to create a new feature branch on which to stage and commit their changes. they'll run through the same edit stage commit pattern with all the changes and push their branch to the remote server. Next, I want to walk through some Git branching strategies with you. With GitLab, you can use any branching strategy you like. I want to go over some common ones and share the pros and cons of each. Organizations coming to Git from other version control systems frequently find it hard to develop productive workflow. Git flow is one branching strategy. This strategy suggests a main branch and a separate develop branch with supporting branches for features, releases, and hot fixes. The development happens on the development branch, moves to a release branch, and is finally merged into the main branch. This can be confusing because the standard practice in Git is to have your main branch be the default or deployable code. GitHub introduced a simpler flow that enables creation of feature-specific branches that are then merged into the main branch. But this approach doesn't address the realities that many organizations have multiple environments, releases, and integrations. GitLab Flow solves this challenge by integrating the Git workflow with an issue tracking system and ability to create dedicated branches for environments and releases. GitLab Flow incorporates a pre-production branch to make bug fixes before merging changes back to main before going to production. Teams can add as many pre-production branches as needed, for example, from main to test, from test to acceptance, and from acceptance to production. GitHub Flow is where you might have a long-running dev branch, then merge to main when you do a release. In GitLab Flow, you've got short-lived feature branches with main-based development, and everything is coming off of the main branch. So with the GitLab Flow, the primary benefit here is being able to leverage environment branches. And GitLab Flow lets you incorporate differently named environment branches that are automatically updated to the main branch. For example, let's say that you have a staging environment, a pre-production environment, and a production environment. With this flow, essentially teams practice feature branching while also maintaining a separate production branch. GitLab Flow decreases the overhead of releasing, tagging, and merging, which is a common challenge encountered with other types of Git workflows. So with this recommended flow, you could first deploy the main branch to staging. Then to deploy to pre-production, you would create a merge request from the main branch to the pre-production branch. Finally, you would go live by merging the pre-production branch into the production branch. This workflow, where commits only flow downstream, ensures that everything is tested in all environments. If you need to cherry pick a commit with a hotfix, it's common to develop it on a feature branch and merge it into the main branch with a merge request. In this case, do not delete the feature branch yet. The main branch passes automatic testing. You then merge the feature branch into the other branches. If this is not possible before manual testing is required, you can send merge requests from the feature branch to the downstream branches. You can also use release branches to release software to the outside world. In this case, each branch contains a minor version, for example, 2-3-stable, 2-4-stable, etc. So for a recommended flow here, you create stable branches using the main branch as a starting point and branch as late as possible. By doing this, you minimize the length of time during which you have to apply bug fixes to multiple branches. After announcing a release branch, only add serious bug fixes to the branch. If possible, first you should merge these bug fixes into the main branch and then cherry pick them into the release branch. If you start by merging into the release branch, you might forget to cherry pick them into the main branch, and you encounter the same bug in subsequent releases. Merging into the main branch and then cherry picking into release is called an upstream first policy. Every time you include a bug fix in a release branch, increase the patch version by setting a new tag. Some projects also have a stable branch that points to the same commit as the latest release branch. In this flow, it is common not to have it's not common to have a production branch. All right, so let's get the terminology out of the way, and actually let's see the issues in practice with a bit of interactive command line time working with Git at the command line. So here's some high-level steps for getting the Git CLI setup on your local machine, depending on your operating system. I won't go into detail here, but you can navigate to the reference link below here, and we'll provide the slides after this webinar, so you can get access to this URL. But depending on your operating system, you'll have different instructions to get Git CLI set up. Next, in order to communicate with the remote GitLab server, you'll need to create an SSH key, which is an access credential that's used in the SSH protocol. You'll generate the key locally and then save it in your .ssh folder on your local machine where you're doing the development. To authenticate and communicate with the GitLab instance from your local machine's Git CLI, you'll need to add the SSH key generated to your GitLab account through the web interface. And just like the previous slide, I won't go into too much detail here, but you can navigate to the link referenced here at the top for more directed guidance. And as a security best practice, I recommend generating a new SSH key for each device that needs to communicate with GitLab using the Git CLI. For example, your desktop and laptop machines should use a separate SSH key that is each uploaded to your GitLab account on the web interface. That's to ensure that if one device is lost or stolen, you can maintain access on the unaffected machine while removing the impacted SSH key from your GitLab account. When you first install Git, you'll need to configure your user information to identify who's making the commits from Git CLI. You can check the settings here with the git config --list command. So you can see that here for my local machine. I've given you an example of what my local configuration looks like. The username is Chris Guitarte, and I've got my email address listed there as well. Next, in the Git workspace, you'll choose a directory on your machine that is easy to access. I recommend you create a new directory called workspace or development. This is where you'll work from to add or change the repository content. First, I'll clone a repository, project repository in that directory that we'll be working with today. Here's an example of me creating that directory, navigating to that directory and doing the git clone command using the git URL to clone that into my local workspace. When you're working locally, you may not always be in sync with the latest changes on the remote repository if you've cloned from a remote GitLab project repository. I recommend you use these commands to update your local repository after cloning and to get the status of local changes that you've made. Here you can see that some remote changes on the readme.md file have been updated, removing some lines, and using the git pull command, I've updated and merged those changes to remove some lines on my local repository. Using git status, I can see that everything is up to date with my main branch now. So you can see that there. Doing git fetch, applying my passphrase, doing git pull, entering my passphrase again, seeing that changes there, been made locally, and finally putting git status there to see that I'm all up to date. Continue on, I want to show you how I create a new branch locally and make a quick change. Create a new branch and check out a new branch. I use git checkout -b and the name of the new branch. I switch to the new branch. Now I run git status to see what's going on. I want to go ahead and edit the README file using my favorite editor, Vim. I'm going to add some changes here, changing the salutation from hello to welcome, and then saving those changes. I'll exit out and then run git status to see the changes locally, see that things have been modified, do a git diff and see actually what changed from the old version of the README file and the new version. So hello has been removed and I've added welcome and a comma. So let's stage the change using git add, commit the change using git commit, and push to the remote repository using git push to the remote GitLab remote repo. Here you'll see that I've added the README file, done a git status to see that I've modified that README file, adding a commit with the commit message. That's confirmed there. Doing git status, see that there's nothing else to commit. Using a git log to see the changes of that commit. Doing a git push to the origin and the actual origin repo and the feature branch that I want to push. entering my passphrase, and then seeing that that branch has then been pushed to the remote repository. So now that we pushed our feature branch to the remote repository, we can work on getting feedback and validation by creating a merge request. In the merge request, you can check out the changes made and mention different folks to provide feedback on your changes. You can make changes again in your local repository, push them to the remote server, and you'll notice that the merge request will update. When you're ready to merge this code to the main branch, you can click merge. So here you can see that I've created the merge request, reviewing some of the changes here, and looking at some of the changes, making some comments here. After adding that comment from the diff or changes page, you can go back to the overview page, and you can see that within the activity feed there as well. You can keep the conversation going in a thread. Here I wanted to say, let's ship it, adding an emoji, adding that comment as well. But you might run into a situation where we need to make some additional changes. So that's where I'll take you here in this next slide. You can make changes again to the local repository and push them back up to the remote repository on GitLab. And then you'll notice that the merge request will update with those changes. So here, we're going to add some extra emphasis to the salutation, adding some additional exclamation points. We'll save the changes. Go ahead and check the status, see that we've modified the README file. We'll add those changes to StageM again. We'll commit them, adding a commit message, adding lots more emphasis here. And then we'll go ahead and push that back up to the GitLab remote repository. Right, it's been pushed up. So now we'll go back to the merge request and see that those additional changes have been made. We've added, we've got some feedback from another team member saying we need more emphasis, adding more exclamation points. So here in the diff, inline in the activity feed, we can see those changes have already been reflected on the remote repository. Once we've done that, we've resolved the thread, adding comments, say thanks for the feedback, and we'll go ahead and merge those changes into the default branch by clicking the merge button. Once it's merged, we can go back to the project repository. Looking at the main branch, we can see that those extra emphasis, the extra emphasis has been added. All right. Finally, I want to share with you some resources to help you on your journey to start using Git on GitLab and some additional tips that I'd like to share. So here's a couple of resources that I would recommend. First being a game that you can play in your web browser to learn Git commands and branching in a visual and interactive way. It's really fun, I definitely recommend it. The second is a Git commands cheat sheet that you can download and reference, and it's created by GitLab. You can always reference it directly in your web browser, or you can print it out. Next, we've got some helpful migration links. If you have a long history working with another SCM tool and you want to bring all that history over to Git on GitLab, these resources are available to you so that you can either self-service your migration, or if accelerating your time to value is important, you can have our professional services team take the lead on migrating for you with our migration package. Again, we'll provide the deck after the webinar is completed, so you have access to all these links. I also want to leave you with some advice if you're coming from CVS, SVN, or TFS. So unlike centralized version control systems, with Git, each developer has their own copy of the repository. This means you can commit as often as you want without affecting others. Even if your changes are incomplete, breaks an API, or causes the build to fail, you can commit. This allows you to structure your commits as logical units of work, as opposed to one monolithic commit that represents the entire new feature. In Git, all operations are atomic. Either they succeed as a whole, or they fail without any changes. In CVS, for example, commits and other operations are not atomic. If an operation on the repository is interrupted in the middle, the repository can be left in an inconsistent state. If you get into trouble, lose commits, or find that you've broken everything, turn to your ref log. The ref log in Git will show you all of your recent repository activity, and from there, you can reset your repository to any of the previously committed code. And in most centralized version control systems, updating your local source tree to match the repository cannot be taken lightly. If you made significant changes, updating from head can cause a huge headache. This is because you're essentially fetching the new revision and merging it with your source tree. In Git, the concept of fetching and merging can actually be applied separately. With fetch, you only retrieve the metadata of changes. When you also want to download the actual changes, you do a pull. A pull operation always includes a fetch operation. Branching and merging in CVS or SVN is a pain. In fact, until the code is properly merged and committed to head, I don't consider it complete. Git, on the other hand, stores the relationship between commits as references, which enables much better branch support. Creating a branch is as easy as creating a pointer to the latest object in the tree. For this reason, I suggest creating a branch whenever you start working on a new feature. At any point, you can merge or rebase with the main branch, as well as share your branch with others for easy collaboration. Separate branches makes it very easy to move effortlessly between tasks. All right, well, I want to thank everybody for joining my webinar today. I'll pass things back to our host, Taylor, for some housekeeping items, and with time permitting, I may be able to access or address some of the questions live on the call.
Thank you, Chris. Yeah, I'm just going to open up a quick feedback poll. Looking forward to receiving some feedback from you all. Just a couple of quick questions on that. And with that, yeah, I will go over a few questions here and ask those to you, Chris. The first one here, what do you think is the best branching strategy?
Yeah, great question. So it all really depends on your team's expertise and release deployment strategy. I presented 3 options earlier with the Git flow, GitHub flow, and GitLab flow. But with GitLab, we don't necessarily force you to use one or the other. It's entirely up to you and your team how you want to implement your branching strategy within GitLab. So I definitely recommend you review all of our documentation around the different branching strategies and choose the one that best fits where your team is at today and how your team is actually releasing and deploying your code.
Awesome. Next one here. Can I edit files directly using Git on the GitLab web interface?
Yeah, great question. So I know we focus a lot of using Git on the Git CLI on your local machine, committing those changes locally, then pushing them up to the remote repository, which is GitLab. But if you wanted to, you actually can utilize the built-in web IDE now based on VS Code to create new feature branches and start a merge request all from your web browser for really quick changes. I'm going to switch over to the other tab here in my web browser, and you can see here there's a web IDE button. You can click this button to open up another tab with the VS Code based web IDE. You can see here all the files in this project repository and click on the README file. So for example, if I wanted to remove all this extra emphasis, I can do so directly in the web IDE, just adding a period there. Clicking on this branch button, I can add the commit message, removing all emphasis. Commit and push that new change. And I want to create a new branch. We'll go ahead and click yes here. It suggests a new branch name, main patch, and the hash of that commit. You can leave that empty to use the default. Hit enter, and it'll go ahead and create that branch for you. And you can create an MR or merge request directly from that web IDE interface. You can click that. You see the new merge request, removing all emphasis. You can assign to yourself, assign a new reviewer, and go ahead and create the merge request. So it's a really great way if you wanted to make some quick changes without having to, do all the work locally, stage the changes locally, and then push them to the remote repository. We can do that all directly within the GitLab user interface.
Great. Last question I'm seeing here. How long should you keep feature branches?
Another great question. So there actually isn't a specific time frame that I would recommend, but as a best practice, I would recommend using short-lived feature branches as much as possible. When you use a short-lived feature branch, it allows you to make smaller iterations to your code base and really makes it a lot easier for your team to review your code. So the example that I showed here, if the change was really just to, remove the emphasis on that salutation in the README file, if I were to add additional changes to other files on the same feature branch, it becomes more difficult to review the code in the merge request. But if all I want to do is remove all the emphasis on the salutation, and I just look at the changes here, I can see that pretty clearly that only the README file has been changed. But if this becomes a little bit more monolithic of a feature branch, a lot more long-lived, you'll start to see a lot more changes here on this changes tab, and it becomes a little bit more difficult to review and actually make that quick iteration to the README file. So definitely recommend short-lived feature branches as much as possible, and it just makes it a lot easier to review the code.
Great. Thanks, Chris. And again, thanks everyone for joining us today. Glad you took some time out of your day to learn GitLab with us. And like I said, you will be receiving the recording here in the next day or so. And with that, we'll wrap up for today. Thanks, everybody.